We're going to talk about why we want to do it and some of the ways we can achieve it. This may be a good news or a bad news, depending on how you see it. This has got absolutely nothing to do with .NET. Got absolutely nothing to do with Java. Nothing to do with just about everything. It just has everything about you, what kind of discipline you can have and some of the practices you can implement. And so from that point of view, the bad news is I'm not going to give you a tool to use. The good news is, I'm hoping, that I'll give you a lot of things to take home in terms of how you can change your own personal practices and team development practices. So we'll get started. The best time to ask a question or make a comment is just about when you have it. I'm going to have a bit of difficulty seeing you if you raise your hand. So just yell out, make some noise or call Venkat, and I'll immediately, or within a very short time, yield to your question. Make it interactive. I really like to, have people ask questions to participate. There's absolutely no question that's trivial, or simple or stupid. So always don't hesitate to ask questions. So let's get started. What are we going to talk about here? We're going to talk about a number of ways we can improve the code quality. But why do I care to improve the quality of code? That's the first question. So one of my passion is in Agile Development. So what is Agile Development? Agile Development is where you are making an effort to stay in tune with the evolving expectations, evolving requirements, changing requirements. And how do you do that? Now, let's say you go to the customer and say, you are important. Tell us what you want, and we will change the application accordingly. And your customer begins to tell you what they really want, and while they are telling you, you just realize, wait a minute, the last time I touched that piece of code, I did not go home for the weekend. Forget about this Agile stuff. I want to go home, right? So in other words, if your code is of extremely poor quality, you cannot possibly be Agile. So you cannot be Agile if your code sucks, right? That's one of the reasons why you want to improve the quality of your code. So question is, how can we do that? What are the things that can help us to do it? So what is code quality? What does that mean really? It's an extremely subjective thing. Now, this is a quote that I really like a lot. It says, programs must be written for people to read and only incidentally for machines to execute, right? If you write a piece of code, but nobody can understand it, this could be yourself after a vacation, right? You're looking at the piece of code and you don't have a clue what it's doing, right? You're complaining. You're saying, who wrote this code? And about 20 minutes later, you realize it was you who wrote the code. It doesn't look as bad anymore, right? So, if your code is of poor quality, it becomes very difficult to maintain this code. So you want to make sure that the code that you write is easier to understand, easier to work with. Well, that's easy to say. How do you do that? But more important, why do I care to do this? I've got some customers, I've got some clients, and the problem they are facing today is they have huge applications that's making them a lot of money, but the problem is their customers are coming back to them and saying, okay, this application is great. There is always this but, right? This application is great, but we want you to modify these things for us. And then they go back and change these things, and then they realize that a lot of things that worked before doesn't work anymore. Or they go back and change these things, and their head spins, they don't understand what this is doing, and they're not able to maintain and release the next version of the product, and then that becomes a problem for them to keep up with. So when you are dealing with an application, the larger the function point of your application, the more the change is going to be. If somebody comes to you and tells you that they implement code, they implemented a project, but they never changed it, what they're telling you politely is that their project got canceled, right? If a product is of any value to anybody, it's something that's got to evolve constantly. You've got to be able to maintain it. So if you have a problem in the code, if you find and fix the problem as soon as you write it, let's say that's going to cost you $1 to do that, right? Now, let's say that you don't fix this problem, you don't even know about it for, let's say, 2 weeks or 3 weeks, or even in cases where you don't even know there's a problem for about 2-3 months. So one fine day, while you're working on this important task, somebody tells you that the code you wrote earlier doesn't work anymore. So what's the first thing you're going to do? You're going to drop what you're doing, right? So the task that you're working on is going to be delayed. And then you switch over to that other task, and you look at this code, and you say, is that code I actually wrote? I don't even remember working on this stuff, right? If you're like me, what I did 10 days ago is something I don't even remember anymore, right? And so you have to context switch. Context switching is expensive. And then the minute you context switch, then after about 20, 30 minutes, if you're lucky that is, you say, oh yeah, that should be a less than equals, not a less than. I'll go fix it, right? Now, remember how much time you had to waste. You couldn't attend to what you were working on. You had to context switch to attend to what you're looking at right now. And that is pretty expensive to do. And also, if this is a problem that was found in production, it's not only you trying to find this problem and fix it, it's everybody else involved in this, right? Including the customer who has wasted time in fixing it. So if problems are found later in the game, it costs a lot more, sometimes 100 times more to find and fix the problem. In 2006, the US itself, just one country, right, spent $60 billion, that's 60 with a big B behind it, in finding and fixing software defects. This is not money spent in product development. This is money spent in fixing bugs, putting out fire. And if you can take some of that $60 billion and put it to good use to improve the quality of the software, it's well worth the time and effort to do that. So question is, how do we go about doing this? So in terms of reducing the software defect, right, you want to be able to find and fix these problems sooner than later. As soon as you write it, if you can get a feedback, that's much better than finding it later. 40 to 50% of effort on projects is avoidable, work that you can avoid redoing over and over and over. How many times have you been sitting and working on a code and you're like, I don't have to do this again, right? This is something that I could have done better the first time around. No need to be doing this over and over. And 80% of avoidable rework comes from 20% of defects. That's actually a good news. This is a report by Boehm. You can take a look at it. These are the references at the bottom, so you can take a look at some of these and read if you're interested in reading a little bit more. And again, 80% of defects come from 20% of modules, and 90% of downtime comes from 10% of defects. That's actually an encouraging news, right? So if you can focus on this area of code and make it right, that's good already. Now, I want to spend just a couple of minutes on this, but I'll talk a lot more about this later on. Peer-based review catches about 60% of defects. So one of the best ways to find and fix software defect is to have peer-based review, code reviews. And I'll talk more about this a little later on. But the next point actually hits it on the head. It says that a perspective-based review catches 35% more defect than non-directed reviews. What does that mean? So when I say that I'm a huge fan of code review, I want to emphasize this. In some companies, they hire these senior software developers, and then these guys don't write code anymore. Most of the time, they have this title called architect, right? And then what do? They sit in a chair, and they come to work with a big cane, and then they said, I'm going to review your code. I call that the priesthood-based code review. Don't let priests review your code, right? Because they don't have a clue what they are actually looking at. And then they will tell you that your curly brackets are in the wrong place. Who cares where the curly bracket should be, right? There's a lot more to code review than looking where the curly bracket is. So the perspective-based review is extremely important. So the person who's reviewing your code must be your colleague. This is the person who could have modified the code last week. This is the person who could have modified the code next week, or somebody who closely works with you, who can get his or her hands dirty and start modifying the code. So it's a peer-based review that's very important. Do not submit yourselves to priesthood-based code review. That is extremely dangerous to have. That's not value at all. So in terms of one of the things that's most important, that's why I started out this session saying it's about you, it's about personal discipline, right? There's this saying, you can take the horse to the water tank, but you cannot make the horse drink it, right? If you and I, at the end of the day, does not have the concern and the care to sit down and do a better job, nothing is going to do this. If you say, oh, my manager doesn't want to do this, my colleague doesn't want to do this, there's one term for all of those, right? Those are excuses, right? If you are thoroughly convinced this is the right thing to do, you will find a way to convince everybody around you, right? So that's a personal discipline. So at the end of the day, when I sit down and start writing my code, if I am not disciplined, nothing counts after that. So a personal discipline is extremely important, and it can reduce the defect introduction rate. It's not reducing defects, right? It's reducing the defect introduction. I used to work with one guy. This guy was a disaster, right? He would come to work half a day, and then we had to tell him to take the rest of the day off, right? Because if he stops coding, the bug rate goes down, right? And we would have to hire 3 people to work for him because they would have to undo everything he did in the morning and redo it, right? That's kind of like the guys you don't want to entertain. You want people to write good code and then have a good discipline and write a better quality of code. It costs 50% more per source instruction to develop high dependable software product. So, get that in your mind. If you are going to develop quality code, well, there's news for you, right? That's going to take time and effort. It's not something that comes for free. So if you don't want to spend the time and effort to create a good quality code, it's not going to happen. It's not something that's going to just happen by magic. And again, 40 to 50% of user programs have non-trivial defects. But still, the evidence is overwhelming around us. But I find that oftentimes we never seem to have time to do it. But we always have time to redo it, right? You go to companies and you say, hey, this is what we should do. We don't have time for it. And then you create this mess. And then they're like, okay, now how do we fix this? Now they want to give you 2 years and $20 million to fix the mess you created, but they cannot give you the time and money to do it right the first time. It's an extremely reactive society that we live in, right? So what are the ways that we can improve on the quality of code that we develop? So one of the first things we should take care of is this concept of technical debt. So software has a tendency to rot. Software doesn't follow the law of physics, but there are a couple of things that gets it. One is this concept of entropy, right? Andy Hunt calls entropy as, it's like he compares software to cheese. You put it out and it begins to smell and rot after some time. So you got to constantly keep the software intact. You got to maintain it. And so you got to take care of the software quality as time goes on. And it's something that you got to constantly pay. Now, how does this come to this point? A lot of times when you're sitting there to write your code, you know as much as anybody else in this room, right? You're so glad this darn code works, right? You've been at it for about 2 hours. The time it compiles and produces the right result, you're like, oh my goodness, finally this nonsense is working, right? And then you move on to other things. You come back after 2-3 days, look at it, and you're like, okay, it works, but it could be better, right? There are shortcuts you took, there are things you did, and that's probably not the most elegant thing. And what happens if you just don't worry about it, right? Then you pile up a lot more code on it, and about 6 months later, about a year later, it becomes extremely difficult for you to go back and modify this code. It is very expensive. So this is like a financial debt, right? If I use my credit card, I keep charging my credit card all through the day and the rest of the week and the rest of the month. Well, guess what? At the end of the month, I think it's a good idea to take some money that I get as an income and pay off the debt. Now, if I say at the end of the month, you know what? The salary I got so many things that I would rather spend on. What happens? My credit card debt is going to increase. So what does the credit card company do? They come to you and say, well, you have exceeded your credit limit, so we are exceeding your credit limit even further, right? But why? Because the credit card companies don't want you to get in trouble. They want you to get in real trouble, right? And so you get into this disastrous situation. Then what do? If you have the capability, you grow a beard, change your name, and go to another state, right? Well, that's kind of what happens if you don't pay your financial debt on time, just like how you got to take some of your money and pay off those things. On a project, you got to take the time to pay this technical debt. If you don't take the time to pay your technical debt, eventually the software becomes a nightmare, right? And nobody wants to work on this code. You wake up in the morning, and then you take a deep breath and say, I got to go back to work today to look at that stupid code again, right? And nobody wants to go back to work. It becomes a burden. You don't want to get into that situation. So the question is, do you know what the technical debt is on your project? Are you scheduling time in every iteration where you can pay off the technical debt? That's something that you want to start thinking about if you don't already do that. So like I said, software is a measure of the quality of the software design and implementation. It's very subjective. It's something hard to measure, but you got to be careful what you are going to measure. One of the metrics, for example, is a line of code, right? That's not a very useful measure. Hey, what does it mean? Does it mean if you write a lot of code, that's good? Or does it mean if you don't write a lot of code, that's good? How do you measure this stuff, right? I had a client that will remain unnamed here, but in their infinite wisdom, that company told their employees that their bonus will be based on how many bugs they fix. And the employee, I said, oh my goodness, that's bad. And they said, no, that's good. I said, how is that good? They said, well, we worked really hard in this iteration to put the bugs, so that we can get it out the next iteration and take the bonus, right? That's kind of the way things work sometimes. You've got to be careful what kind of measure you put in place, and you want to make sure that it actually improves the quality of your system or application that you're developing. So think about ways you can improve. So it's like I said, it's highly subjective. It's highly qualitative. It's not so easy to quantify it with a number of 1 to 10, but we're going to see a few ways to do that today here. So is the code readable? Is the code understandable, right? A lot of times you write the code, but is the code easy to understand, easy to follow? Now the code must be something that's easier for follow, but who should follow the code? I'm not asking you to walk to the streets and bring this one guy on the street and say, read my code, right? It's your colleagues. Are they able to read the code, understand them? That's very important for you to think about. Is the code verbose? Sometimes it's good, sometimes it's not good to be verbose and so on. Are the variable names meaningful, right? Is the class names meaningful? Can you read that and understand what this particular thing stand for? Does the code have test cases? Is there a proper coverage for the test cases, adequate test that you have? Or is it a simple code that actually works? Or is it completely complicated, nobody can understand it? So those are some of the things that you want to ask yourselves. So some of the ways that you can improve the quality of code, the first recommendation is start very early, right? If you are on a project, if you start applying some of the ways to improve the code, techniques to improve the code very early in the game, it becomes easier to maintain it. If you wait for like 7 years and one day you go on and turn on tools and look for these things, it becomes overwhelming, right? You get thousands of errors, and what do you do when you get thousands of errors? You say, you know what, turn it off, right? We don't want to look at it. We don't have time to fix all of this. So start very early. Now, of course, that's really useful if you're on a new project. So one of the things we do on new projects is we have what's called an iteration 0. Why is that iteration 0? Well, if you're on an Agile Development, iterations are usually pretty intense. And you get started with iteration 1, everybody has tasks to complete, and that's exactly what's on everybody's mind. And you say, okay, but while you're doing this, somebody's got to set up this cruise control or continuous integration. Somebody's got to think about these tools and automation and so on. Nobody wants to build a cat. Everybody says, look, I've got enough stuff on my plate, I'm not going to do it. So you can have an iteration 0. It doesn't have to be an entire length of an iteration, but that iteration's focus is to get the tools up and running and set up a certain process that you want to use. Well, what if you're already on an existing project? Well, there's really no reason why you cannot declare an iteration 0 just about any time. So you say, well, in 2 weeks, we're going to start iteration 0, and our focus in that iteration is to evaluate some of the techniques and ways to improve our code and so on. You could certainly do that. Don't compromise, because the minute you start compromising, then you're saying it's okay to have code with errors. It's okay to have code that nobody understands. And then slowly but surely, it becomes a disaster, right? It becomes unmanageable, unmaintainable. Schedule time to lower your technical debt, I mentioned that. And another thing important is, this is a slogan you got to keep in mind. Make it work, make it right. Because a lot of times what we try to do is we try to make the code really pretty. We try to make, really improve the quality of code. But even before the code starts doing what it's supposed to do. So don't sit there and refactor. Don't sit there and make it pretty. Just get the code working. And once it works, then you say, okay, now that it's doing what it's supposed to do, I'm going to go back and make the code better and improve it and refactor it. You got to kind of have this discipline to separate these two. And this is something that requires monitoring and changing your behavior. So one of the ways you can do this is to make these things visible, right? Now, I was talking to a company and I asked them, how many warnings they have in their code, right? And nobody could tell me that number. And if you don't know what it is, how could you improve on it, right? So I was visiting a company, and as I was pulling into their building, one of the things I noticed was they had a huge bulletin board, and they had information on different projects they have in the oil field, and what their safety record has been, how many times they have had failures, when was the last time they had failure, and so on. And I was thinking, you know what, if this is something they post where everybody entering sees, and if your project is on that list, what's going to be on your mind, right? So think about this for a minute, right? Just go back to your office on Monday, or whenever you go back, and print out the number of warnings you have, the number of bugs you have in your product, the amount of test coverage you have. Print all of these and post it by the coffee machine in huge font. And then see what happens over a couple of days, right? And people start talking about it. And as these number varies, how do people react to it? That's one of the ways to know. If you cannot measure it, how can you improve it? So make it visible. And be very willing to help and be helped, right? Be willing, be open, right? It's a good, healthy thing to accept criticism, right? Hey, how can I do better? What am I doing better, that I could change and I can improve? That's only a good thing. And again, in all of these, don't go back and invent a very heavyweight process and tell everybody you're going to endure this painful thing to do. Then nobody wants to do it. It's got to be an extremely lightweight, non-bureaucratic way of doing things. So I'm going to talk a little bit about what can you do as an individual, right? What is that you and I, when we go back to our own desk, each of us can do on an individual basis. So the first thing is we should care for what we do, right? And care about the design of your code, right? Talk about, hey, is this a better design? Is it a poor design? Can I improve this design? Can this be done a little bit better? So one of the things I have enjoyed over the past few years is working with some really brilliant people, really good experts. And one thing that surprises me the most when I work with these experts is they would come over to me and they would say, well, here's an idea, here's the design, here's the code. I hope you can take a look at it and hope you can improve this. I would say, wait a minute, this guy is an expert that I respect, but he comes to me and says, here's something and I hope you can improve it. Why is that, right? Then I realize something. Anytime they come to you and say, can you improve this? Then that means they're extremely open to do things better. Almost anytime somebody comes and says, this is a masterpiece I created, you better go do this, and you look at it and it's like, man, this is really bad, right? So that's the way to learn. Be very open and say, how can I do this better? You care about and improve it. Does your variables have good name? Is your class small? Is your method small? Have you ever looked at a method that is 700 lines long? Right? Some of us brave enough maybe will admit that we wrote them, right? So if you have a method that's 700 lines long, what's wrong with the 700-line method? It's a ball of mud, right? It just starts it and it goes on and on and on and on, and then goes on more, and halfway through you forget what it's doing, right? It's extremely difficult. Now, sometimes you will hear people say, this code is not testable, right? You take that word, this code is not testable, and then translate to English. It reads this way, this code sucks, right? A lot of times, if you cannot test a code, that's a reflection of extremely poor quality code, right? Now, I won't ask you to do this, but if I ask you to raise your hand, if you believe that, exercising is good for health, right? Everybody in this room will raise the hand saying exercising is good for health, right? But if I tell you to leave your hand up, if you actually exercise, very few of us in this room will leave the hands up, right? Now, why is it that most of us think exercising is good for health, but very few of us actually do it? If you want to know all possible excuses one can give, call my wife and ask her, right? I have given every possible excuse. She's a caring woman, right? She would say, you got to exercise. Oh, I would say, oh, no, I've got this book due next week. I got this article due next week. I got to finish this project. Always, it's the short-term goal that's more important than the long-term gain, right? And I think that software unit testing or software testing in general is the software equivalent of exercising. Most software developers will believe that testing software actually improves the health of your code, but very few people actually want to do it. We come up with all kinds of excuses. So you have to take the personal discipline to say, well, I'm going to write code that is testable. Now what happens? You write a 700-line method, you realize quickly, there's no way in the world I can write a test around this method. So what do you have to do to make that code testable? Well, you start breaking that method into smaller pieces. Well, guess what happens if you break a method into smaller pieces? The method becomes about 4, 5, 10 lines of code, but it'll do one thing and will focus on doing one thing. Hey, what's that concept called? That concept is called cohesion, right? So your code becomes more cohesive, which is a good design principle anyway, right? So as the code becomes smaller, testing forces you to make your code more cohesive. Well, what if my code has great dependencies? Well, it's hard to test my code when it has great dependencies. So what do? You start loosely coupling your code. You start breaking the dependencies, and as a result, your code becomes loosely coupled. Well, guess what? That's another good design practice, right? You want your code to be more cohesive, and you want your code to be loosely coupled. Well, look at what happened. You started out to test this code, and in the process of testing, you realize you cannot test this ball of mud. Then you start breaking this method into smaller pieces, or when you start writing the method in the first place, you keep it smaller and more cohesive and loosely coupled. And as a result, a code that's being tested ends up being a better design. So one of the ways that testing helps you is that it improves the quality of your design, because it's very difficult to test poorly designed software, right? So testing actually forces you to improve the quality of your system, and that's a nice thing, right? So if I want to stay thin, if I'm healthy, guess what? I don't have to take medicines, I just have to exercise. Exercise improves the quality of health and your shape. In a similar way, your testing improves the quality of your system and its shape as well. So that's a way to improve it. Also, a lot of us have looked at a lot of bad code, right? But when you look at a good code, don't keep it quiet. Spread it around. Tell other people. You show the code and say, hey, look how beautiful this code is, right? If you find good code, don't keep it quiet. But don't look at your code and say, look how beautiful this code is, right? That is called bias, right? So if you look at somebody else's code and you really like it, tell people, right? For example, right, one of the software I like a lot, and it's pretty popular out there, is Spring. If you look at Spring code, what you will quickly realize is Spring methods are very small in size, right? You're going to look at about 4, 5, 6 lines of code. Spring class names are long. Spring method names are long. So they're very descriptive. So you want the class names and methods names to be bigger, but the method sizes and class sizes to be small, right? So one of the ways to know that it's a good code is to look at some good code and appreciate it. Next time you start writing code that comes to your mind and like, hey, why do I want to write this method this way? Well, because that happens to be a good code. You can also read books on this topic, right? So one of the books out there is called Beautiful Code, right? So if you go to the library, or if you have a library in your office, try to get access to this book, or go to the bookstore and look for it. Beautiful Code was written by about 33 different people. These were people who are well known in the field, language creators, framework creators, and so on. And they talked about various things they have done and other people have done. And it's a way to read this and say, you know what, they're talking about how you could recreate this code and start appreciating code quality, right? You tell other people, hey, look at this, how beautiful this is, and so on. And you can learn a great deal from doing that as well. So learn from reading good code. Keep it simple. That's not easy to do, but try. Write tests and keep your coverage really high. We'll talk about this a little bit more as we go on. And also run your test before you check in code. Check in frequently. You want to check in code several times a day, right? You want to check in code every few minutes. Sometimes I run across developers and they say, well, we check in code once in a few weeks. I just sit there and I'm stunned, right? How could you check in code every few weeks? And they say, well, that's actually frequent for us, right? That just scares me, right? I cannot keep a code with me for more than a few minutes. The other day somebody said, yeah, really? Well, show me how many times you checked in code today. I said, sure, and I ran through Subversion log and had about 100 check-ins that day already, right? And it was only about 3/4 of the day already that day. And you may say, are you crazy, Venkat? Why do you check in code so often? Well, checking code is like a leash on a dog, right? If you have a nice dog, you put a leash on it, you take it for a walk, your dog can wander away and smell the bushes and so on, but you can always, bring the dog back, right? You've got a leash and you can pull it back. Let's say I have a piece of code and I've not checked in the code for 5 hours. Now I come up with a great idea. You always come up with a great idea, right? And you're like, hey, what if I write the code like this? And you're going to say, oh, no, but I have to be very careful, right? Why? Because if you mess up, you're going to lose all your 5 hours of work, right? And you're going to be walking like you have a very full glass of milk, right? You don't want to do that. Well, check in the code, and guess what? You try some wild, crazy ideas. If it doesn't work, what do? Blow it away, get the code back from the source control system, and you can change it any way you want to, right? That gives you a great amount of agility because you can go wildly and try out concepts, ideas, and thoughts, and if that is not what you like, you can go back and change it. The other reason is, almost any time I've looked at a code and worked with it for about 4 or 5 hours, at the end I realized that I've overly complicated that code. So if I work on it for a couple of hours, sometimes I'll just throw it away, think about this for a few minutes, come back and try it, and usually the code is much simpler and quicker to write. And that's one of the ways to really write complicated code is just sit on it for too long without checking it in. So check in very frequently as you develop the code. Also, if you're learning languages, thoroughly learn what your language is, right? There are idiosyncrasies you got to know. If you're mixing different languages, you got to be very careful about it as well. And also, again, like I said, code criticism and gain feedback. Keep it simple. This is a little picture of this guy, Rube Goldberg. He used to draw all these comics, and he would come up with weird ideas of complicated things to do simple things, right? This is a machine he invented to scratch his back, right? And if you think about it, a lot of us have written this in code, right? You go back to your project and you look at it, you got a really complicated code that's scratching somebody's back, right? And you're like, hey, if you want to scratch the back, that's pretty easy to do. You don't need something very complicated. I was looking at a piece of code this guy had written. He had about 80 lines of code that took a data set and converted it to XML, right? And then he sends this XML over to this function, and another 80 lines of code that parses the XML and creates a data set. I'm just sitting there and scratching my head. Why did he go from a data set to XML and XML back to data set, right? Maybe he wanted to learn XML, right? Maybe that was not needed. This actually is a very famous design approach, by the way. Somebody said this is called RDD. It stands for resume-driven design, right? You do stuff because it will improve your job prospect, right? Hey, does the project need it? I don't know, but I want to learn this, right? Well, if you want to learn it, go do this elsewhere, right? Your poor project is not the one that is, desiring to have this. So, just ask yourselves, is this really part of my solution? Do I really need this, right? And only do what actually makes sense on your project and keep it pretty simple. Ask yourself, Einstein said, any intelligent fool can make things complex, but it takes a touch of genius to make things simple. So don't mistake, simplicity is something that's very hard to realize. But what's wrong with simplicity, right? Most of us don't feel good to make things simple, right? Let's say you create a design and you show it to your team leader or a colleague, and he or she looks at it and says, yeah, that's simple, right? You look up at the guy who gave this, and he's like really down. He's like, what do you mean it's simple? Give it back to me, I'll be back, right? And I'll make this complex and bring it back to you, right? If somebody looks at it and he's scratching his head and doesn't know what's happening, this guy is beaming with pride. Yeah, it took me 4 hours to write it. At least take you 8 hours to understand it, right? So, complexity is like donuts. You eat them, you feel good, it fills up your stomach, you want more of it, right? Well, it takes a certain amount of effort, and sometimes it's perfectly okay to keep things simple, right? There's nothing wrong with it. What's good about simplicity? You know what? If it's simple, you can understand. If it's simple, you can maintain it. If it is simple, you can just get your job done and go home and evolve things. If it's so complex, it's hard to really get the work done. In the name of extensibility, we a lot of times add so much complexity to the code, it becomes almost impossible to maintain this code. I want you to think about this. I don't want your code to be complex. I want your code to be capable, right? So you don't measure by saying, I'm working on a large application. Some people pride that, right? You say, really, how large? Oh, about 6 million lines of code. What does it do? Nothing, right? But why do you have so much code? Oh, because we just like to write large code. It's extensible. For doing what? We don't know yet, but it's extensible, right? What's the point, right? So ask yourselves, is my code capable, right? So you measure quality of your software by saying, well, it's an application that's useful. It does all these good things for you. How big is the size? Not a whole lot, right? So it doesn't have to be big by its size. It's got to be big by its capability. So that's something you need to ask yourselves and keep in mind. This is a beautiful phrase. There are 2 ways to construct software. One way is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated there are no obvious deficiencies, right? You don't even have a clue what's wrong with this. Versus, it's simple enough, there's nothing wrong with it, right? So you choose which one of these 2 you really want to create. So I talked a little bit about what can you do as an individual, what are the things you can do as a team, as a collective team, a set of people, right? So avoid shortcuts. Take collective ownership. Have you worked in companies where they say, well, this is Mahesh's code versus this is somebody else's code, right? We take territorial ownership of code. That's a bad thing. Why is that a bad thing? Well, have you ever worked in a company where your boss one day says, whatever you do, don't touch the piece of code. The guy who worked on it is no longer here and nobody understands the code, right? And some of the terms I really like it is, one day the boss comes to me and says, we poured concrete over that code, right? What a beautiful way of saying, that's bad code, nobody understands it. right? These are called euphemism, right? You say bad things in a nice way so it doesn't really hurt you listening to it. It's like, in those days, remember those days when we used to have software bugs and then they would send us, patches? Have you ever seen a patch in the recent years? No, because there's no software bugs at all, right? All of those are features and we keep getting service packs, right? Because it sounds so much nicer, right? What do you mean you got a patch? A service patch is really nice. Similarly, there used to be a time when you would say, he's stupid. They don't say that anymore, right? Because you offend people. You say, he's interesting, right? So when you say he's an interesting person, you just say he's a stupid person. Nobody has problems anymore, right? We got challenges, and interesting people have challenges to deal with. So, the question is, how can you deal with some of these things? So you want to write code that's maintainable. How do you write code that's maintainable, right? If I keep writing code and nobody looks at my code, what happens to my code? Nobody will be able to understand that code. Who can maintain it? Only me. You say, okay, Venkat, but what happens if you take a vacation? Well, that's simple. My boss never gives me vacation, that's why, right? And if you take a vacation and come back, you won't understand it. So he says, look, if you're gone, nobody can maintain the code. You stay here and maintain that code, right? So what happens eventually? Well, this is called a truck factor. So what is a truck factor? So truck factor is the number of people in your team who should be run over and get killed by a truck for your project to fail. What's the truck factor on a lot of projects? 1, right? One guy gets run over by a truck, you say, uh-oh, did he die? Yeah. Well, nobody can maintain this code anymore. We'll pour concrete over it, right? I was talking to a guy in London and he said, oh, this actually happened on our project. I said, oh my goodness, I'm so sorry to hear that. He said, no, it was not a truck. On this Monday morning, this guy comes laughing. He says, I won a lottery ticket, right? He won millions of pounds and he came to work and said, I don't have to work anymore. And he laughs and leaves the building. The project goes under. I said, you know what? I think you guys would have been happy if we got killed by truck, right? This guy actually won millions and you still end up, failing on your project. You don't want to have that truck factor, right? So what do? You have a collective ownership. If I, work on a piece of code, I want you to work on the piece of code the next day, right? If you work on the code, maybe the third day, you can work on the piece of code. So what happens in this case? This code gets looked at by different people, and it becomes easier for other people to understand. Not in theory, in practice, because other people are trying to understand and maintain this code. Now you can, as time goes on, this code is much more readable and understandable because different people end up working with this code. Now, collective ownership is not difficult to do, but a lot of times politics and our approach to things really make it harder for us to do these things. So give it a try, see how you can implement this collective ownership. You may say, okay, Venkat, that's nice to hear, but there are times when we have extremely advanced code. Maybe there are only 3 people in the world with a degree who can understand that code. Okay, yeah, there are special cases like that. Even then, assign a buddy to this guy and say, hey, look, your job is to just work with him and try to understand as much as you can. And just another pair of eyes looking at it can improve the code already. Provide constructive feedback. Constructive feedback is extremely important, right? You don't want to say, that's stupid, right? Instead, be proactive and say, how can you improve the method? Rather than saying, that's stupid, you wrote long methods. Instead, say, why don't you break this method into smaller methods? Now you're telling what to do rather than saying what you didn't like. So be very constructive and give good feedback. And, constantly do code review. Now, the minute I mention the word code review, generally a lot of people laugh. They say, code review, are you crazy? It never works for us. Here's the reason why code review never works, right? Have you ever worked in a company where for code review, they bring the entire team into a room on a Thursday afternoon, right? And then they project the code on a big screen like this. And then they sit there and say, that code is not good. Has that ever happened, right? Now, what happens when you have code review like that, right? The guy who wrote the code says, look, are you guys going to get together on Thursday afternoon and beat me up? I'm not interested in this code review, right? And this other lady says, look, I'm already behind schedule. All that I want to do is get my work done. I don't want to waste my time looking at the stinking code that he wrote. And the project manager says, look, the last time you guys had a code review, there was a fight. We had to call the security, and one guy actually quit. No more code review for you, right? Well, code review never works that way because it becomes extremely political. But we have used code review very effectively. How do we do code reviews? The way we do code reviews is it's extremely tactical, right? So if I write a piece of code, you're going to do the code review, right? The next time I write a piece of code, it's a task. Maybe I spent about half a day writing it. and you're going to do the code review, right? So who are these two people? Well, these people could be the people who are working with me closely. They could be writing the code. They could be modifying the code. It's a peer-based code review. But notice how tactical this is. We're not really bringing everybody into a room, and I just give a piece of code to her to review. The next day, I give him a piece of code to review. Nobody is beyond code review. The code he writes similarly gets reviewed by one of us, and we rotate this among the peers in the group. We give comments, and we move on. This has been extremely valuable for us. And you know, one of the best ways to keep the bug count low. I had a client, and I asked the client, hey, can I use developers in India to develop this code? And my client said, look, I don't care where you bring the developers from, but if your code doesn't work, we'll hang you. I think that was pretty clear what they wanted, right? So every line of code I wrote was reviewed by somebody over here. About a line of code that anybody wrote here was reviewed by somebody back in the US. And we had a way to review this code very critically. And nobody was beyond code review, right? It's not like a code written by one group of people got reviewed by another group of people. We were constantly reviewing everybody's code. Anyway, I was mentioning this to a group of guys, and one of the project leaders in the company said, hey, that is exactly what we do in our company for code review. I said, wow, that's amazing to hear. Tell me a little bit about what you think about it. And this is what he said. He said that code reviews make me a hero or make me smarter. I said, wow, that's brilliant. Explain to me what that means. He said, a lot of times when he gives a code for review, people would come back and say, why don't you break this method into smaller methods, what have you? And every time they say that, he's becoming smarter, right? Because he's learning from them how to write better code. But once in a while, they'll come back and say, that's pretty darn good. I've never seen the code being written that way. I'm going to go back and do the same thing on my own code. And that's the time when it makes them a hero, right? Because they are understanding and learning something in the process of reviewing the code. If you approach code review with that kind of attitude, where it either makes you a hero or makes you smarter, why would you not want to do code review in your project? So again, a couple of references here. Rigorous inspection can remove up to 90% of errors even before the first test case is run, right? That's how significant code reviews are. I cannot tell you, if you ask me, what are 2 best practices that I can ever think of applying on projects, right? What are the things I would want to consider using on my projects and evaluate constantly? I would say, hey, do I want to use code reviews? Do I want to write test cases? Those are the most important things in my opinion. Reviews are both technical and sociological, and both factors must be accommodated, right? It's a human activity. You want to be sensitive to them and approach that from the point of view where you're providing value, addressing the emotional concerns and ego and so on. So just a quick small set of notes, other ways to improve quality of your code. Treat warnings as errors, right? So if you have a lot of warnings in your code, you don't even have a clue what kind of bugs are going to creep in. So say that I want to treat warnings as errors, right? So if you start treating warnings as errors, you can then fix them right away and move on. Well, what if you have a project where there's thousands of warnings? What do you do about it? Well, yeah, you cannot fix all the warnings overnight. If you can, that's great, but if you cannot, what do? Well, write a little script and set a threshold and say, look, we will not allow any warning to go beyond the count we already have, right? So if you increase the number of warnings in your code, immediately your build will fail and you'll get notified. And set the threshold so that if you start fixing the warnings, the number goes down. So you never let the warnings increase, and hopefully over the next 3 months to 6 months, a lot of warnings will disappear in your code. That's a good way to approach it. And of course, if it's extremely unavoidable, then of course, selectively suppress it, but don't assume it's unavoidable, right? Challenge it and say, hey, is this really unavoidable? Is it unavoidable because I don't have a clue how to fix it, or is it unavoidable because it's really unavoidable? Go ahead, please, but a little louder voice so I can hear you. So the question is, hey, if I write the code, how does somebody, understand the code? Do I just send them the code, they understand it, or should I sit there and explain it to them? Remember, one of the goals is that you want to write the code in a way that others can read and understand it. I'm glad you asked this question because I kind of forgot to mention something. So a lot of times when they read your code, they should be able to understand what your code is doing. Yeah, there are times when something could be a little bit complicated, but those are more exceptions than a norm. And of course, they can quickly ask you, right? If you're nearby, they could just come and ask you. If you're on IM, they could chat with you and so on. So one of the things that we also do, we don't only read the code and review it, we also review the test cases that go with it. So a lot of times I worked with some really brilliant developers, and a lot of times I would go back to them and say, well, you know what, your code is good actually, but you forgot to write these 3 test cases. So I would actually, my review back to them would be to add more tests or add some special tests. So the reason I brought that up and you kind of triggered that thought in my mind is, even if sometimes the code is not very clear, tests are a way to document your code. A test kind of plays out the story as to what you're expecting, and that should be fairly easy to understand. And sometimes, honestly, developers come back to me and say, hey, Venkat, that code is good, but it took me a few minutes to understand it, so I recommend that you rewrite it this way. And that's a good feedback to have. So the answer is, yeah, you let them kind of take a look at it. Hopefully they understand it. If not, then they come back and interact with you. But again, there's no rule. You just find what works the most for you. But keep it low bureaucratic. Don't say that, well, from tomorrow, we will follow this, and here's the tool we're going to buy for doing this. Then people start putting off things. Find extremely low ceremonial approach to get that done. Yeah, good question. Trade warnings as errors we talked about. Look at the code coverage. How much of your code is being tested, right? If code coverage, unfortunately, is like cholesterol number, right? You go to the doctor and he says your cholesterol is high, blood pressure is high. What does that mean? Well, you got to fix a lot of these things, right? So the doctor says you're not in good health because your cholesterol is high. So you work really hard and you lower the cholesterol number. You go to the doctor, what does the doctor say? Does the doctor ever say your cholesterol number is low, you're in good health? Does he say that? No, he says your cholesterol number is low, we hope you're doing well, right? It's kind of, discouraging when you hear that, right? But it's kind of like that. Just because the cholesterol number is low doesn't mean you're in good health, but higher cholesterol number certainly means that you're not in good health. Code coverage is exactly like that. Low code coverage is a problem, but a high code coverage doesn't mean everything is good, right? You don't have that problem, but there may be ulcer you have to deal with. So keep an eye on the code coverage. You keep an eye on complexity of your code. Why is something we need to worry about complexity? Because if the code is very complex, it's hard to maintain this code. Look at the code size, right? And also look at duplication of code. But do you think that duplicating code is a bad idea, right? It certainly is, right? But why do people keep doing it? Why do we duplicate the code? Say that again for me, please. That's the path of least resistance, right? Hey, look, that code was there. I wanted something very much the same, but not quite the same. I copied and pasted the code. I'm not messing with you, right? Nothing is going to break because I copied and pasted it. You do this like 8 times, what happens? Now you have 8 versions of this code. And when I found a bug or enhancements, what do? You fix in 4 places, and what about the other 4 places? You forget, right? And then eventually it comes back and hits you as a bug, and you go fix it. So is duplicating code good? It is extremely good if your brother or sister works in the QA. You can keep the family employed, right? I write code, you fix the bug, we both are employed, right? But that kind of becomes very tough after a while. So no, it is extremely bad. You don't want to be duplicating code. So those are the things you want to look for. So how do you deal with code coverage? Well, there are tools that can help you to look at code coverage, right? There are tools like, Cobertura and JCover. In the case of .NET, there's tools like NCover and so on. One of the interesting tools there is a tool that says if this code is never tested, why not get rid of the code? And rightfully named, if you follow politics, it's called Guantanamo and Ashcroft, right? So it's a tool that goes and looks for code that's never tested and literally removes that code. I'm kind of scared to run that. It may leave an empty directory on some projects I know of, right? So it actually gets rid of code. You ask yourself, if the code is never tested, what does it mean? If the code is never tested, it means that that path has never been exercised, right? Just because the code compiled doesn't mean it's right, doesn't mean it's going to work, right? And then what happens if that path is never exercised, if the path is never tested, about 2 years into production, one fateful day, this one customer, right, clicks on this button, a certain set of events happen, and that code that never got exercised wakes up and says, wow, they called me, and it causes a riot and leaves a burnt hard drive behind, right? You don't want that to happen. You want to run every piece of code. If a code doesn't deserve to be tested, remove it. So strive for a very high coverage of tests. What does it tell you? It tells you that the code is covered. What does it not tell you? It doesn't tell you if the quality of the code is good. You want to reduce the complexity. Why? Long methods are hard to understand how to maintain. A lot of these variations in path really lead to excessive complexity. And it's very, and sometimes you commenting code, I'm not a fan of commenting code. I cringe anytime somebody says comment this code, right? Why? If you're, this is one of the pet peeves I have. Have you ever seen this? I scream when I see it. So I saw this guy writing code one day, and his code was like this, class car, and then he says, public car, and then constructor, right? And I scream, right? Why do you say it's a constructor? Well, guess what? If he doesn't know it's a constructor, he has no business touching this code, right? And so that is a pretty stupid comment, right? Doesn't help anybody at all. So, and again, yeah, you could write a comment, but never write a comment that tells you how the code works. Guess what? That's what you have the code for, right? Here's the way to think about it. Trying to comment a code is like trying to explain a good joke. Have you ever explained a good joke and people still think it's funny? No, it's like the good code, right? Just write the code and people should get it. If not, rewrite the code, don't comment it. So then what? Commenting should be reserved then for telling why the code exists, what its purpose. Anything special and weird that it's going to do, focus on that in your comment. You probably have seen this also, right? Somebody copies and pastes this code, modifies the code, the comment still says the old thing, right? You're like, which is true now? Is the comment right or the code right? It's quite confusing, right? So be careful with these comments. Large classes that are hard to maintain, break this into smaller classes. So there is a Cyclomatic Complexity by Thomas McCabe, and he talks about the number of edges and the number of nodes that a code has, and it's a way for you to measure the complexity of your code. And you want to measure the complexity and you want to lower this complexity of your code. So take a look at Cyclomatic Complexity if you're interested in. Again, a list of tools that deal with this. So again, a Cyclomatic Complexity, why is this a big thing? A highly complex code requires more tests. And to a certain time, after a certain point, it'll be so complex that it's impossible for a human to write the test at this point, and then you give up. So the only way to solve the problem is to reduce the complexity. So you want to know what your complexity level is and try to reduce it. So what does it mean? It gives an indication of the degree of hardness of your code. It still does not tell you the degree of defect in your code. Keep it small, right? You want to keep things small. Keep the methods small. Keep the classes small. It's easier to understand, easier to maintain. And so, how small is small? Small means that you should be able to see the entire code in a window. Now, don't try to lower the font size, right? In a reasonable font size, you should be able to see the entire code, about 10, 15 lines of code. I usually linger around 10 plus or minus is a good thing to do. So, keep it dry, right? There's something called a dry principle. If you've never read a great book, you cannot go home today. You got to go to the bookstore before you go home today. And that book is a must-read book for any programmer, and that's called Pragmatic Programmer, right? By Dave Thomas and Andy Hunt. So it's an outstanding book. Every programmer in the world should read this book. So one of the things they talk about in this book, Pragmatic Programmer, is the so-called dry principle. Dry principle stands for don't repeat yourself. It is not just duplicating code, it's also duplicating effort in your code as well. So you certainly want to take the time to avoid the duplication of effort in your code along the way. So, ask yourself, there are tools again to look at duplication of code, right? So, and there are tools that will go find these duplicated code and refactor them. Again, all these tools can be there unless you put in effort to run them, you won't get any benefit. Okay, you can say, all right, Venkat, we talked about some of these concepts. Let's put them into perspective. You could say, well, if the complexity is low and the test cases are low, that is still a high risk, right? Because you still don't have good test coverage on your code. If the complexity is low and the test coverage is high, that is good, right? That's low risk. You want to be on row number 2, right? That's what good things are. If the complexity is high and the test coverage is low, that is high risk. In fact, that risk is higher than the higher before, right? That's why it's in bold case. And if a high complexity and high test automation, that is medium. You say, okay, that's all great. We kind of understand this conceptually, but how do you put a number to it? How do you quantify this, right? On a scale of 1 to 10, tell me how good I am. How do you do that? Well, this is where Bob Evans and Alberto Severa came up with a brilliant idea. They call this a CRAP metric. right? So what's a crap metric? Crap, of course, you know what the word crap means. A lot of us write shitty code, right? So they decided to give this name called crap metric. And this is an experimentation tool, and of course, in this case, crap stands for change risk analysis and prediction. And they measure the cyclomatic complexity of the code. They also measure the code coverage, and then they arrive at this number for this. This is a relatively new experimentation tool. There is a tool called crap4j, which is for Java. Like I said, they're playing with this and getting feedback and so on. So what they did was they measured the crap, they call this the crap load, and they measure a value of between 0 and 31. Of course, 31 simply means that the code is crappy, right? It's beyond repair. You might as well, throw the project away if you cannot fix it and improve the code complexity. Of course, the lesser value is better, but of course, you want to have more tests as much as you can in this code. So they say that the 30 is a threshold for the crappiness of your code, and then you can measure the scrap load and maintain your application and kind of keep an eye on the system as the system evolves. I've merely touched on some of the things. I'll kind of skip through that. So how do you identify code smell? Code smell is something you got to be aware of. Constantly you got to say, how do I improve the quality of code? And there are several smells you can identify. There's just not one or two. Duplication is one. Unnecessary complexity is another. We talked about this a little bit. Misleading comments, long classes, long methods, and so on. And tight coupling, right? Trying to be very clever, right? I'm sure you have seen code like that. You look at the code, you scratch your head, you don't have a clue what this code is doing. And the guy is like, isn't that really cool, right? And he does some really big twiddling, and he says, well, that's kind of cool because it improves performance, right? That's just purely hypothetical probably at the time, right? Nobody understands this code, but this guy is so happy because it works, right? That's kind of the worst thing. The code works, but nobody knows why, right? That leaves you with much of a worry, right? You kind of stay awake in the night. Why does the code work? I don't understand it, right? So you want to remove some of these smells. So take a look at this example here. I love this. It doesn't even want to go show the code. Nice, nice. Look at the code. Are you able to see it from there? Right? It says class enum, E extends enum E. Right? You look at that code and your head spins. What does that mean? Right? That is an example of a clever code, right? It's hard to understand, right? This is purely from Java, right? This was introduced in JDK 1.5. This is how enum is defined, right? And try asking somebody to explain what that does, right? And then you hear them look, think down, right? It's like, what does that do? That's an example of very clever code. You don't want to write clever code. You want to write code that's easier to understand. So keep an eye on this complexity. Pay your technical debt. Clean up the code. Remove the smell as we go along. I'm going to skip this part here. It talks about how to write better quality of code. Keep it simple, keep it clear, keep it brief, consider the humanity of the code. We can go into more details later on. So a couple of things I want to say. Okay, so don't be clever, instead be clear. Here's another nice quote. I never make stupid mistakes, only very, very clever ones, right? And we all have made these clever mistakes along the way. Again, take the time to write good quality code. Don't rush. I like this quote again, act in haste and repent in leisure. Code too soon and debug forever, right? How many times we have tried to write code in a rush and it doesn't work anymore? So take the time to write defensive code. Take the time to write tests, right? I cannot overemphasize that. And also write self-documenting code. I want to spend just a couple of minutes on this, writing self-documenting code. There are tools that can help you to write code, but at the end of the day, you got to take the time to write code that others can understand by giving descriptive names. At the top is actually a true example from production code, right? A developer, poor guy, had put this code, that God help me, I have no idea what this means, right? It's frustrating when you see variables that have no meaning in the code, and it's frustrating for a maintenance programmer years later to look at this and say, what does this mean really? So look for these code size, write a code in a descriptive way. I want to mention this a couple of things. Today we are in a world where developers all over the world are working on code base, right? In the case of Groovy, for example, right, the Groovy developers, a lot of them are in Europe and US. A lot of them are non-English speaking people. And how do they maintain the code communicate? Ruby was written by a Japanese, right? And how do you, read and understand Ruby implementation? When Dave Thomas and Andy Hunt sat down to write the famous Pickaxe book, they looked at Ruby code and they were in a state of shock because all the comments, as you would probably expect, were in Japanese. And neither one of them knew Japanese. They were like, oh my goodness, what do we do? as soon as they got out of that initial shock, they started reading the actual code that Ruby was written, and to their pleasant surprise, they were actually able to understand the real code, right? This is credit to Marx, the creator of Ruby, where even though he's not an English speaker, his code was understandable, even though his comment was alien to the people who were trying to read and understand it. That is what we want to try to do, is to write code that's self-documenting and conveys the meaning of what we're trying to do. So document the code by writing the code in a descriptive way. And the last thing I will say is, if your code has errors, display the error. Make it extremely easy for you to find these errors. If it takes you a lot of time to find these errors in development, it only is an early warning sign. It's going to be a nightmare in support of your product later on. So make it extremely easy to see these. So let me summarize quickly what we talked about, right? The first one is practice tactical peer-based code review. Consider collective ownership. Consider untested code as unfinished code. That is something you want to keep in mind. Make your code coverage and metrics visible so that people can know where you stand if you're improving along the time. Don't tolerate anyone trashing your code, right? Take it extremely serious. And also, I would say, write self-documenting code and comment the whys your code exists. Use tools to check the quality of the code as time goes on. We talked about a few tools. And use the tools continuously. Don't just start using it one day. It gets overwhelming. Use it constantly, continuously. Treat warnings as errors, I mentioned. And also keep it small and keep it simple as well. So a couple of different references for you if you're interested in looking at some of these references. And that is all I have. Questions, comments?